Today we'll be reviewing how to complete the square. But before we do this, we need some background work. We first need to recognize what perfect squares are. Perfect squares can be written as something squared. So for example, 9 can be written as 3 squared. X squared can be written as x squared. And 25y to the 8th can be written as 5y to the 4th all squared. You do have some other examples like x squared plus 4x plus 4, which can be written as x plus 2 all squared when factored. Now, when trying to complete the square, what we're aiming to do is to write sum or the entire expression as a perfect square. Most times you will get to write only a part of the expression or polynomial as a perfect square and not the entire thing. But we will be looking to do something like this. Now notice that part of your polynomial is x squared plus 4x. And generally what we need to do to complete the square is to add in some number, in this case 4. And so we're going to consider a few examples where we complete the square given only a part of your polynomial.
Hey, if you haven't liked, shared, or subscribed yet, go do that now. Okay, bye.
Let's take a look at x squared minus 12x plus 11. Now from here, it is easy to recognize that x minus 6 all squared will be the perfect square that we'll be working with. If it's not as obvious, you can simply divide your b term or the coefficient of the x term by 2, and that will tell you how to structure your perfect square. Now, I want us to keep in mind that x minus 6 squared is x squared minus 12x plus 36 when multiplied. So then, if I have the part of the polynomial x squared minus 12x, what I need to complete the square is actually just 36. But I have 11. So what I will do in this case is just add in 36 so that I'm able to complete the square. So I have x squared minus 12x, and then I will add in 36 to complete the square. Of course, it's not enough just to add 36. We can't just add 36 randomly, so we need to also subtract 36. But keep in mind you do have positive 11 as part of your polynomial, so we add that 11 as well. So again, this is still x squared minus 12x plus 11. But we did add in 36 minus 36, which is 0. That way we do not change the value of the polynomial. And you can add in 0 in any form. It could be 10 minus 10, it could be 50 minus 50. It doesn't quite matter, just as long as whatever you add in, you also subtract to not change the value of your polynomial. Now that we have our perfect square, then we will write this part as a perfect square and then simplify whatever is left over. So x squared minus 12x plus 36 we established was x minus 6 all squared. So I'll write this as x minus 6 all squared, and then negative 36 plus 11 is negative 25. And so this is how we complete the square of a polynomial. Let's take a look at another example. So this would be example 1. Let's take a look at example 2. Now sometimes you are not given the expression in this form. Sometimes it's written as an equation. So you'll have n squared is equal to 18n plus 40. Now the thing to do here, just like we've done before, is to bring everything on one side. This will become n squared. If it is positive on the right, this 18n will be negative on the left, so it would be negative 18n. And this positive 40 on the right would be negative 40 on the left, and that side would be equal to 0. So notice that we just subtracted 18n and subtracted 40 on both sides, and so basically moving everything onto the left side. Now this part looks a lot like what we were working on before, and so we'll continue to do that. Now again, we want to complete the square. We need to recognize first what square we're working with. This is n minus 9 all squared. And remember, the reason we know this is because we take the b term, or the coefficient of the n term, and we divide that by 2. So 18, negative 18 divided by 2 is negative 9. So that's how we know that that is the perfect square that we are looking for. This simplifies to n squared minus 18n, and of course negative 9 squared is 81, positive 81. So the first part is n squared minus 19 or minus 18n, and we have to add in 81 to complete the square. So we'll do that right here. So n squared minus 18n. To complete the square, we add 81, but remember, we immediately have to subtract 81 and then bring down the negative 40 we had before, and now this is equal to 0. So we cannot just add in the 81, we have to also subtract it so that we're only adding 0, thus not changing the equation. So we'll take this part and write it as a perfect square, which is n minus 9 all squared, and then we'll simplify negative 81 minus 40, which is negative 121. And this is equal to 0. Now if you'd like, you can bring this 121 over to the other side. And so if it is negative on the left, it'll be positive on the right. So this would be n minus 9 all squared equal to positive 121. Now this is method 1 of completing the square if it is in the form of an equation, meaning it has an equal sign. There is a second method. If this method is understandable to you, then that is fine. You can skip to the next example, example 3. However, if it's not so clear, maybe this method would be better for you. So this we'll call method 1, and this we will call method 2. We're going to take n squared equal 18n plus 40. And we'll follow the same second step to bringing everything on one side except the 40. So we'll take n squared. The 18n that is positive on the right will be negative on the left. And we'll set that equal to 40. So here we only have the first two terms that we want to use to complete the square. Keep in mind that we are going to use n minus 9 all squared as our perfect square. And so here we need to add in 81 to complete the square. So we have n squared minus 18n, but now let's add in 81 on the left, but using our properties of equality, whatever we do on one side, we must do on the other side. So again, this expression is still n squared minus 18 still n squared minus 18, still equal to 40, but in this case we are adding in 81, and whatever we do on one side, we must do to the other side. And that's by properties of equality, the addition property of equality. Now this perfect square is n minus 9 all squared, as we established. And then 40 plus 81 is 121. So notice that the answers are the same, regardless of what process you choose. And so if working only on one side works best for you, then you can do this method, or if working on both sides is good for you, then you can do that method as well. Hope this helps.